We're all familiar from early childhood with the concept of centripetal force and centripetal acceleration, which occur as we go around a radius, like a car that's making a banking turn, or when we run and we try to change directions rapidly. So if we think of going around a circle that has a radius r, and we're moving with a velocity v, then we feel a force that pulls us outward, and we have to exert an equal and opposite force toward the center in order to maintain that velocity going in this direction. Although the velocity is constant, and this is called the tangential velocity because it's tangent to the circle, and if, for example, this is a car going around a circular racetrack of radius r, then you can see that we have to constantly pull inward. We do that using the tires and the steering wheel to guide the car in a circular path. Now, that requires a force to counter the natural centripetal acceleration that aims outward from the center of the circle. What is that acceleration, and how do we define it? The answer is the centripetal acceleration is the square of the velocity divided by r. The first thing to notice about that is it depends upon the square of the velocity. You can check the units also. The velocity squared is going to be a meter squared over a second squared, and we're going to divide that by a radius, which would be a meter. So you can see that we end up with a meter per second squared, which is the correct units for an acceleration. Now, this centripetal acceleration quadruples when we double the velocity. So if you go around a curve in a car at a speed of, say, let's say 25 miles an hour, and then you speed up to 50 miles an hour, you're going twice the velocity. So you would take 2v and square it, so that would give you 4 times the previous centripetal acceleration. And so the centripetal acceleration can really sneak up on you. It goes as the square of the velocity. And now that we have the centripetal acceleration, centripetal incidentally means moving toward the center, we can look at what the period is of the motion, because often it's easier to know the period of something going around a circle than it is to know the tangential velocity. This is true if you're slinging something around in a circle, like a bucket of water, a problem we'll solve later. And so if we think about a radius r, then we know that we have a distance around the circle of 2 pi r, and that's going to be equal to the tangential velocity, v tangential, times the time it takes to go around the circle one time. That would give us the circumference of the circle. So obviously from this we can compute the tangential velocity and get v tangential is equal to 2 pi r divided by the period of the motion. We can therefore plug this into this equation up here and get that the centripetal acceleration is equal to the square of this term, so that would be 4 pi squared r squared divided by t squared divided by r, and from this we can see that that because the r squared appears up here and the r appears down here, that we lose that square, and we end up with 4 pi squared r over t squared. Now, having the knowledge of what the centripetal acceleration is, we can then go on and say, what is the centripetal force? Centripetal force is the mass times the centripetal acceleration. So it's going to be mv squared over r. And of course, we'll calculate that in some simple ways. Let's say you have a racetrack of r is equal to 20 meters, and you have a velocity of let's say 30 meters per second, which is pretty fast, going around that circle, and maybe this is a mass of let's say 5 kilograms. Then we can compute what the centripetal acceleration is. It would be v squared over r, so it would be 30 squared divided by 20. And then we would multiply to get the force. We'd multiply that by the mass, which would be 5, and that would give us our centripetal force required to hold that in. So the acceleration is 30 squared over 20. That would be, let's separate that out. A centripetal would be 900 over 20, which would be 45. And that would be meters per second squared. And then when we multiply that by 5, we would get the force. I think I did that right. 45, that's correct. And we multiply that by 5, 5 is 25, and a 2, carry a 2, 4 5 is 22, and that would be in newtons. So this is how we would calculate the centripetal acceleration and the centripetal force for a simple problem. Be sure you remember this equation right here.